Hi, welcome to E2E Cloud's machine learning series. In this video, we learn machine learning in 3 minutes. Any AI algorithm is really just a massive math problem. You take a bunch of inputs, perform hundreds of equations on those inputs, and arrive at the desired output. Each one of these circles represents a math equation. Each line between two circles represents a variable, or weight, that is learned over the course of a process called training. Weights allow for different strengths of relations between these circles, or neurons, to be determined that can help a neural network figure out a final classification or prediction. The stronger the connection, the higher the weight value. In order to learn the values of the weights that give a machine learning algorithm its unique connection-based value, a neural network needs data. The machine learning algorithm takes the massive dataset and learns patterns it can use to determine how to get to that output. Training data allows the computer to look at thousands of examples to perfect its technique. Test data allows the programmer to test how well their algorithm is able to perform on data not found in the training set. Here's what would happen in the training process of the MNIST dataset. First, all of the handwritten digit images are fed into the model. Then the sequence of pixels in each image is multiplied by a set of weights. The product is then fed into the next layer. This process continues layer after layer until an output layer is reached. Yet another function, in this case, the softmax function, is applied to the set of values in this output layer. Lastly, a prediction is calculated and compared to the ground truth label, which is a label contained within the original dataset that states which class the image actually is. The real magic of a neural network happens after the prediction is calculated, contrary to what you may believe. The training process culminates with something called backpropagation, which allows the program to go back and adjust any numbers that it believes will help the neural network perform better in the future. It does this by calculating a loss value, which is an indicator of how well or poorly the model has performed on the data. There are many different loss functions used to calculate this value, depending on the type of data being used. An optimizer takes that lost value, uses it to figure out just how bad the model's mistakes have been, and adjusts the weights of the model accordingly. Once the model has been adjusted, the training process begins again. Each time this process runs is referred to as a single epoch. So here's your summary. First feed data into the model, then multiply by a set of weights, and repeat. Then apply the softmax function to the output. The output of softmax is used to predict a class label, then use the loss value and optimizer to go back and fix the weights that are causing trouble. Did you know that E2E Cloud offers the Nvidia A180GB? Astoundingly, the monthly cost is just 1 lakh Indian rupees. Follow the link in the description to sign up for a free trial.